There is a circuit analysis technique that is called the Thevenin method, and it's quite a funny name. But what that Mr. Thevenin said is that we can simplify a circuit down to a voltage source that we're going to call V Thevenin and one resistor we're going to call R Thevenin and the capacitor. This circuit will work in such a way that the capacitor doesn't know the difference. And so this circuit is very useful because we can run through his algorithm. Keep writing the wrong thing here. Should be C1. We can use this circuit and transform it into the Thevenin equivalent. So the first thing Mr. Thevenin says that we need to do is take the capacitor out of the circuit and short out the potential or the source. So that leaves us with the configuration of R1, R2, and R3. And we need to measure the resistance where the capacitor used to be. Well, this is the R Thevenin. And it should be clear that I can move this resistor back over on this side. So resistor 1 and 2 are in parallel, and then resistor 3 is in series with those parallel resistors. So my R Thevenin is equal to R3 plus R1, R2 over R1 plus R2. So that was easy. And now we go back to the original circuit. We have V1, R1, R2, and then we'll have R3. And Mr. Thevenin says we take the capacitor out. This time we're going to measure the voltage where the capacitor used to be. Well, this line through R3 has no path through this other edge. So there's no current flowing through R3. And if there's no current flowing through R3, there's no potential drop. And so my Thevenin voltage will appear between these 2 points. I can move this up here. And now it's just the voltage across R2. Well, we had a nice little function for this. We said if I want to know the voltage across R2, and this is basically a series circuit now, then it was equal to V1 R2 over R1 plus R2, because that's just R1 plus R2. We'll say that was RT, right? That goes back to our other formula. And so now we have this Thevenin voltage, which is just the voltage across R2, and that's equal to V1 R2 over R1 plus R2. Now let's go back and look at our formula that we came up with for using that nice long analysis. VC1 is equal to R2 V1 over R1 plus R2 times 1 minus e to the negative t over R3 plus R1 R2 over R1 plus R2 times C1. And so this can be easily written as our Thevenin voltage times 1 minus e to the negative t over our Thevenin resistance times C1. So we have now found a way that we could solve this circuit very, very quickly by using our Thevenin analysis. Now, we will use this to come up with the answer to the one problem in the homework, but you'll have to figure out how to get from the circuit to the answer that we'll find using this Thevenin equivalent. So you're going to have to use the differential equations to get that to work.